Okay, so this is the next question. Let me write the question down. Let Z10 under addition and dot be the ring of integers modulo 10, and let S be the subset of Z10 represented by 0, 2, 4, 6, 8. Which of the following is false? So we will have to find that out. So A, S under addition and dot is closed under addition modulo 10. B, S under dot addition and dot is closed under multiplication mod 10. C is S under addition and dot as an identity element. As an identity element under addition mod 10. D, S under addition dot has no identity element. Under multiplication mod 10. E, S under addition and dot is commutative. Under addition, okay, under addition mod 10. Now this is an elaborate question. We will have to test everything. We cannot make any random choices, okay, or random guesses. That does not work. So concept understanding is critical. So let's go about this. You can pause the video, try this question out. Now you click the choice. After clicking the choice, you should be really sure the network that is actually leading to the solution, right? So you should be able to give a clear breakup, or you should be able to dissect the solution path. Okay, so you can pause and try, and when we come back, let's see how the solution goes. Okay, I hope you all have got the solution. Let's see how to obtain it. Now we are given, what is that we are given? This is the solution. We are given that Z10 under addition and dot, in this case dot is product multiplication, is a ring of integers, and S being equal to 2, 0, I should place the 0, 2, 4, 6, 8 is a subset of Z10. Now we need to test if S under addition dot, this is already is given, okay, is closed. Our duty is to check if this is closed under addition mod 10. So what is the exact definition? The given set is closed under addition mod 10 if and only if for every a comma b element of S, a positive b is also an element of S such that a positive b gives us a C mod 10 such that this C is an element of S. So that is the basic definition. So let me show you what that definition means. The meaning is S is 0, 2, 4, 6, 8, right? Let me take a being equal to 2 and a b be equal to, say, some 8. Now clearly 2 is congruent to 2 mod 10 and 8 is congruent to 8 mod 10. We know this. Now we add 8 with 2, we get 10. Now 10 is congruent to 0 mod 10 and 0 is element of S. This means S under dot, this is the given set S and the operations are addition and product, is closed under addition mod 10. Okay, so let me go back to the choices. So what happens here is closed under addition mod 10. We just showed that, right? So this is true. Now is it closed under multiplication mod 10? So we have to check that. So let me take S to be 0, 2, 4, 6, 8 and let A be equal to, say, some 2 and B be equal to some 6. Now clearly 2 is congruent to 2 mod 10 and 6 is congruent to 6 mod 10. Now 6 times 2 is what? 12. 12 is congruent to 2 mod 10. Now what is this 2? 2 is contained in this. So this means S comma addition and dot is closed under multiplication mod 10. So the meaning is when we perform the operation, the outcome is also going to be the element contained in the parent set, of course by running it through the mod operation 10. So let's go and check the choice. S is closed on the mod multiplication operation mod 10. Did we not see that? Yes, indeed. Now the next one, S under addition and product or under addition and dot as an identity element under addition mod 10. So let me go to the next set. So we have to show that we need to show that S under addition and dot as an E, okay, such that this E is contained in S and that is the requirement. So let's see how to do that. So we need to show that for every A element of S there exists a E element of S such that A positive E is congruent to A mod 10. This is the requirement. Now we know that S is equal to 0, 2, 4, 6, 8. Now let A be equal to some 8. Then A, or I would say 8 added with E, should give me back A8 mod 10 such that this 8 is element of S. Okay. Now clearly 8 added with this means 8 added with 0 is going to give me 8 and that is going to be under mod 10 and clearly 8 is element of S. Now so this in turn means S as the identity element 0 under addition mod 10. Is it not? S clearly as 0 there. So the identity element is present. So let's go and check the solution list. S under addition and dot as an identity element under addition mod 10. Yes, true indeed. Now S under addition and dot as no identity element under multiplication mod 10. Okay, so let me show you what it means. Okay, for every A element of S, there exists an E element of S such that A times E is congruent to A times mod 10. So we know that S is equal to 0, 2, 4, 6, 8. If A is equal to 8, then we have A operated on or E operated on A should be equal to E operated on A should produce us back our A under mod 10. So to suggest or to state this in simpleness, you can directly state that A times E should give me A mod 10. This is required. So since A is equal to 8, 8 times E should produce me 8 mod 10. So for this to happen, what should you have E to be? For this to happen, E should be equal to 1. But 1 is not element of S. Okay, so can we conclude that S under addition and dot has no identity element? Can we conclude under multiplication mod 10? Can we conclude? That's the question asked. We cannot conclude. No, we cannot conclude, because we need to check. We need to check if S as some other E. Okay, that's always a possibility. It's not necessary that E should always be 1. The requirement is this: 8 operated or the element operated with E should produce us the element back under the modulo 10 operation. That is the requirement. So have that in mind. So now what I wish to do now is to go back and check that out. Okay, I need to check that out. So for that we need an illustration. So now let us check or find out if S as other E. Okay, so this is the identity element check for S. Now let me take A to be equal to 2 such that A times E is congruent to A mod 10. So this is going to be 2 times E is congruent to 2 mod 10. I can rewrite this as 2E congruent to 2 mod 10, which could be rewritten as 2 times E negative 2 is congruent to 0. Right. So 2 goes to the other side, you get a 0 mod 10. This is going to be 2 times of E negative 1 is congruent to 0 mod 10, and this can be rewritten as E negative 1 is congruent to 0 mod 5. Okay, now this in turn can be rewritten as E is congruent to 1 mod 5. So what is the meaning of this? This means we need to find all E's such that E is congruent to 1 mod 5. So the possible E's are what? It can be 1, it can be 6, it can be 11, it can be 16, it can be 21, it can be 26, it can be 31. So you get the point, right? All of these are possible choice for E, but we can only accept candidates mod 10. Okay, so that is the important catch here. So having mentioned that, such that is an element of S. So if you were to take these elements 1, 6, 11, 16, 21, 26, etc., we only have 6 element of S. So our E is going to be equal to 6. Now the question is, will it satisfy mod 10? So we have to check that. So let's do the check. Now we know that S is equal to 0, 2, 4, 6, 8. Now what I'm going to do, I'm going to be taking, say, A is equal to some 4, right? So A times E is congruent to A mod 10. This should hold true. So A is 4. My E, we have found the E to be as 6. 4 times 6 is 24. When you divide 24 by 10, you get 4 mod 10. Now the question is 4 element of S? You see here? This is 6, okay? 4 is over here. Yes, indeed. Yes, indeed. Right? Now let me check one more element. So A is equal to 8. And our E is 6. So 8 times 6 is equal to 48, congruent to 8 mod 10. Now the question is my 8 element of S? Yes, indeed. So this means E is equal to 6 is the identity element. Identity element of S under multiplication operation, or under dot, because it is represented as dot. So probably I will just say under product mod 10. Okay, so what does that mean? That means this statement S under addition and dot has no identity element under multiplication mod 10 is actually false. This is false, because we just showed that there is an identity element. Okay, so this should be the choice. Of course, this is true, right? Commutative operation will hold good under addition mod 10. We don't have to proceed further once we have located, because the question is which of the following is false, right? So there's only one statement which is false. So D is false. Okay, so that ends the question solution. Please like, share and subscribe. Thank you.